Hello students, and welcome back to Chemistry A. I'm Ms. Sleight, and today we're going to be talking about molecular compounds and how to name them. So let's start by talking about covalent bonds and molecular compounds in general, with the example of hydrogen gas. So you have two hydrogen atoms, they each have one valence electron. But instead of exchanging electrons like in an ionic compound, the two come together and kind of share them. In fact, if we were to look at their atomic orbitals, we would see that their orbitals are actually overlapping with each other. This is the definition of a covalent bond. When nonmetals bond to form compounds, their valence shells will overlap and they share their valence electrons. We call the resulting group of atoms a molecule. Let's talk about diatomic molecules. There are 7 diatomic molecules, meaning that in nature, these 7 elements always exist as two atoms bonded together. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And you're going to need to know that these 7 always come as a diatomic molecule. In fact, why don't you take a minute to mark this on your periodic table. One helpful reminder is that you can see that 6 of our 7 elements form the shape of a 7 on the periodic table. These particular elements just happen to be more stable when 2 of their atoms are bonded together. And we use the element name as the name of the diatomic molecule. So typically if someone says hydrogen, especially if they say hydrogen gas, they mean the H2 molecule. As a reminder, the octet rule, or rule of 8, is what governs how atoms bond. So just like how ions would gain or lose electrons to get a full valence shell, molecular compounds are going to share electrons with each other so that all atoms involved have a full valence shell of electrons. So let's look at hydrogen and oxygen here as they make up water. Each hydrogen has one valence electron. If you remember, hydrogen only has the 1s orbital. So if it only has an s orbital, hydrogen only needs 2 electrons to have a full shell. Oxygen, on the other hand, has 6 valence electrons. It's going to need 8 altogether to have a full shell. So what happens is that each of the hydrogens come and pair up and share an electron with each of oxygen's unpaired electrons. And so our Lewis structure for water has 8 electrons all around oxygen and 2 electrons next to each of the hydrogens. So they all are showing full valence shells. Let's look at another example of a Lewis structure for a molecular compound for NH3, ammonia. So nitrogen has 5 valence electrons. 3 of them are unpaired, so it's going to need to be able to share 3 extra valence electrons to have a full octet. Each of our hydrogen have 1 valence electron, so again, they're going to come in and share with nitrogen's unpaired electrons. So our final Lewis structure has 8 dots around nitrogen and 2 next to each of our hydrogens. Now let's talk about how to name molecular compounds. Writing names and formulas for molecular compounds is much simpler than for ionic. There's really only a few rules. The main one being that there's a system of prefixes that are used to represent the number of each atom for each element in the compound. Here's our prefixes. Make sure you get them written down. For one atom, it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. You're going to need to make sure that you know these prefixes for your test and for the exam. Let's look at the exact steps for naming. First off, you want to make sure that the compound is made entirely of nonmetals. That's what indicates to us that it's a molecular compound. Then always use the entire name of the first element. The second element in the compound, change its ending to IDE, and add prefixes to indicate the number of atoms of each type of element. However, when there is only one atom of the first element, do not use the prefix mono. The prefix mono is only used on the second element. So for example, N2O would be dinitrogen monoxide, also known as laughing gas. NH3, its technical name is nitrogen trihydride. However, it pretty much exclusively goes by its common name, ammonia. CH4 would be carbon tetrahydride, also known as methane. So now I'd like you folks to take a second to try and write the formulas for the first two and try to write the names for the last three in this table. All right, let's see how you did. So dinitrogen dioxide should be N2O2, sulfur difluoride, SF2, C3H8 should be tricarbon octahydride, CO2 should be carbon dioxide, CO is carbon monoxide. One more thing to note is that if the prefix ends with an A or an O, and the name of the element begins with a vowel, the two vowels are combined into one. So usually you just drop the vowel off of the prefix. For example, N2O5. We'd need a di on our nitrogen, because there's two, and we'd need the prefix penta on oxide, because there's 5. However, penta and oxide, those are two vowels together. So you're just going to drop the A off of penta and make it dinitrogen pentoxide. And that's all there is to naming and writing formulas for molecular compounds. I hope you guys have a great rest of your day.